So today we're going to be building a kit, but we're also going to be talking about the dice. Now the dice, the family of dice that I'm going to create. Anyhow, if you recall, it was this thing, and I've been looking at ways that I can drive it. And this is a dice kit. So while we're doing the kit, we're going to be talking about how I'm going to drive the dice. Now I've got a few options and some very helpful comments in the last video I did on the dice. So thank you very much. But we'll go through all the other options that we've got. Let's get that out of the way. Right, soldering irons on. So this kit, I don't know how it's driving the board in order to shove up dice, but there are two chips here, so it could well be something like 4017 and using little transistors here to drive it, to channel the current. So the markings on the top of the board don't tell me what that IC is, so we're going to have a look. It's very difficult to read for me, but I think it says 4017BE, so it's a CMOS 4017, which is a decade counter. And what's the other IC? Upside down? Yeah, that says NE555. So we've got a 555 timer and we have a 4017 decade counter. So what it's going to be doing is going to be pinging the 4017 on its clock pin to change the count inside the IC. And I can see some resistors coming down here. They're all 10K driving these transistors. So these LEDs, which are marked with there, they'll all be driven differently through different transistors, I guess. So we won't draw it out completely, but we'll just have a little look at how it works. So I can see we've got a 470 ohm resistor, 470, 470 and a 1K. So it looks like it's pairing two LEDs together. Now, if I were to guess which two those would be, it would be these two here. So while I was knocking up circuits, having a look at different methods of driving a dice, I sort of realized, except I was told in the comments that I should explore it, that not all of the LEDs need to be individual. Now, we do have a schematic here. Well, that is interesting. Let's come in a little closer for you. So it is squashed like that. It's not the video squishing the image. It is just a bit squished. So we've got D4. Let's see if we can find D4 on here. Oh, let's just bring that in. So it's not really up the right way for you to be able to see this, but hopefully we'll be able to figure it out anyhow. So D4 is over here. That's being driven by this transistor. And it's not driving another one. I would have thought that that would also be driven differently. We've got D2 and D4. Why does it say D4 there? Hang on a second. Sorry about that. D4 looked a lot like D1. So D1 is up here. It looks like D4 to me, but so D1 is the central one being driven on its own. That makes sense because it's only ever on for 1 and 5. And then we've got D2 and D4. So D2 and D4. Again, that makes sense. In fact, let's draw this out, shall we? We'll come out a little bit. Hopefully it's still roughly in focus. So for this dice, we can see from the schematic that D1 is on its own. So let's just do D1. And then we also know that 2 and 4 are also on there. So just like that. Now I can see that, does that say D8 and D6? D8? No. It's too difficult to read. Maybe that says 5 and 6, but that wouldn't make sense. Hang on. Right, the print on this is too difficult to read, so I'm just going to tell you what they should be. So the next one along will be the opposing side LEDs, and then only one more, and that will be these two LEDs there. So when we're lighting these up, this is the only combination that we need for a dice. And so someone made me realize that I could probably do this with an 80 tiny on its own. So all those combinations will give you 1 to 6. So that one and that one makes 3, that one, and that one makes 5, that one, and that one makes 6. One of these is 2, isn't it? So that's, oh, and those two are 4. So that's all you need. Anyway, let's carry on. So we can see basically from this schematic how it's working. They're using transistors to selectively drive the LEDs. We've got 10K going to the base of those, 470 ohm resistor for 2 LEDs, and a 1K for a single LED. So that makes pretty much sense. I'm not sure why they've got a transistor over here on the 555. And yeah, that doesn't make very much sense to me, but that's a PNP, isn't it? I don't know, that doesn't make a lot of sense. Anyhow, that's probably just because I don't understand it. So let's get started with this, shall we? So we'll get our resistors in first. Right, we've got all our 10Ks done, and I've found a 1K here, so I'll pop the 1K one in too. And we'll just get the rest of the resistors in afterwards. So the way that I've been thinking about driving this, my original thought about driving a dice was to use an 80 tiny 85 and a shift register, because I figured that would be fairly easy. But I'm just going to move this light back over because it's not doing a great job really far over there. There we go, that's a bit better. We'll brighten it up a little bit. There we go, that's nicer, isn't it? Okay, so we've got our 1K in. So yeah, I was thinking of using a 74HC 595, but the SN version, the lower powered one. And I liked that idea because then I could have animations on the LEDs. It wouldn't have to just only display those particular numbers. But it also increases the cost of making quite a few of them, and the amount of chips you have to solder. So I've got a couple of ideas, and we'll look at those shortly when I get around to about halfway through the kit. I'll pull out the schematics that I've drawn. They're rough, very rough schematics. It's not like I've gone to an awful lot of effort to put detail into them. But I think you'll get the idea. So today is New Year's Eve, and a bit later on today, I'll be going out with some friends to celebrate, which is exciting. It's always a bit of a letdown though, isn't it, New Year's? In fact, I'd sort of rather it just disappear, like pass me by without me noticing. And plus it's always expensive if you want to go out. Or a total letdown. Right, I'm going to put them all the right way around. This is probably going to be the only time that I'll ever do this, because I've just realised that they all have happily gone in the right way around. People sometimes take this time of year to reflect on things that have happened to them in that year. And yeah, I guess I could do that a little bit. I got made redundant. That was a bit rubbish, but I have another job now, so no need to worry about that. But yeah, that was it's not a nice experience. And that is 3.4 meg. Also had a really good time making projects and that, but there we go. But I haven't really, do I? I don't know, you really have to think carefully about your life and what you've achieved. I mean, I could easily say that, no, I can't think of anything, but that could be because I haven't eaten yet. And I'm probably a bit hangry. I don't know, lots of good things have happened and nothing really, really bad has happened. So I think I'm fine. That's 4.4 meg. So I'm going to go for that being the 4.7. Not only will my meter not be able to measure that properly, but there will also be some variance in its value. Oops. And that's about 10. That was 10 meg though. Uh-oh. Yep, I thought so. I've put a 10K inside the 10 meg one. Well, they can continue to be in the right orientation, can't they? So that's good. Thinking a bit more about what I've done this year. I've had quite a lot of fun on YouTube. I mean, I was working with Sion on that Segment display. I cannot really remember what it's called. This thing really needs to go in that little vice thing. Otherwise it's just going to slide around. Yeah, we worked on that. That was a really fun project. It's more of a... I mean, it wasn't all that practical. None of us are going to make our millions off a project like that, but it was enjoyable enough. Should we come in a little bit? Yeah. And we got to know each other better, which was nice. And all of you guys that commented. It was an interesting process. Also sold a product on Tindy for the first time. The binary clock. Oh yeah, I suppose that is something I've achieved. I enjoyed doing that project. Oh, I got in a magazine as well for the first time. I suppose there's a lot of firsts for 2018. That is not soldering. What's wrong with the tip of this iron? All right, we're going to put some flux on this board because that's still not soldered properly. Yeah, I'm absolutely using the iron properly. So I'm just going to put a lot of flux on here just to help it along. That should be everything. What the hell is wrong with that? Well, this pad here is just refusing to take any solder. Well, it has now, but I'm not convinced about it. Oh well, I'll carry on. Maybe I should use some different... There's probably some different solder I can use. Oh well, I've got this one around, so we're just going to use this one. The channel got to 20,000 subscribers, which is fairly amazing because I never thought that would happen. I didn't particularly want it to happen. That's a lot of people to let down every video. You know, one good thing about having a larger audience, because only 10% if you watch any video, like I know that people aren't watching every one of the videos I've put out, and neither would I want them to. I don't watch every video that I subscribe, every channel I subscribe to, I don't watch every video of theirs. If it's not something I'm into, then I won't generally watch it. And that is fine by me. Right, I'm going to say they're all done, but I know what happens with these things. I always miss something. Snips. As predicted, I did miss one just over here. There we go. So next we've got, look at that guy. Oh well, some of these are a little bit out. Never mind. Let's quickly adjust that one though. Do with a little touch more solder on one of those pads. There we go. Oh dear, oh dear. All right, what have we got left? So everything's big now really, so we can basically get it all in. So let's get these transistors in. I don't know the 8050 number. I've no idea what that is. But it looked like a little, was it NPN transistor from the schematic? I think so. And the other one must be a PNP. Hopefully I'm doing it the right way. Yeah, I think so. It'd be funny if I'm not though. We've got a little 100 nanofarad cap. And then our ICs, I'll pop those in last, I think. I mean, I could put them in now, could I? No, I don't think it will sit very well if I do that. Now, can I put it in here? Yeah, I can, excellent. We'll do one pin of the LEDs only, one leg, and then we'll come back and we'll do the rest. But we'll get everything else in. I don't mind if things are a little bit wonky. Just the LEDs would bother me, I think. Bring the iron again, and then just one more over here, I think. I'm just redoing that one. There we go. Right, I'll chop all these leads off and they'll come back. Right, we're pretty much there. There's just a couple of ICs to go on now, but we're not going to do that just yet. I thought we would take a look at the dice problem again. So I've got some diagrams. We know that these are the shapes that we need with those LEDs in order to form every one of the dice symbols, whatever it would be. But when I started out thinking about this, I had a few little options in mind. So this is the option with the AT-Tiny85 running off a 3-volt battery and a 74HC595. Now I haven't gone into detail with these diagrams, it's just literally just to explain the rough workflow, whatever. So you've got a vibration switch here. This is going to be key to it. I'm going to be using a vibration switch in whatever design that I have. I want people to be able to shake the thing. So shake it to get it to display a number or to wake it up or whatever the use might be in the end. So the 74AC would directly drive the LEDs. No resistors in here at the moment, but there will be. Probably a 470 ohm resistor for each one. So that's option one. And it's still a good option. I like it, but it might just be overkill. The other option is, and I suppose it's similar to this in a way, because I'd be using an AT-Tiny85 to trigger the 4017 based off a vibration switch, but it would choose what number it went to. So it would randomly generate a number, and then that would have transistors attached to drive the LEDs, and so it would drive it in that pattern that we talked about. The next option is just to use a 4017 and use the vibration switch to trigger it. Now, I don't know what happens when you trigger one of those vibration switches yet. I haven't looked at it on a scope, and I certainly haven't probed it out with an Arduino yet. I have got some, I don't know where they are now, but that's sort of the next step, is to breadboard it up and explore if you can just use that vibration switch. Is there a lot of bounce on it when you hit it? Is it going to vibrate back and forward in sort of a semi-random way so that we can use that to trigger our number? So that might be interesting. Nice low power solution as well. And then the other one is just using an AT-Tiny85 with the vibration switch, which will, work to not only wake it up from deep sleep, but also could be used as a count for the number. But that is another option, and I like that option because I kind of like the idea of using an 80 tiny 85. But the CMOS man inside me really likes this option. So we'll see. I don't know. Anyway, so those are the options so far. And I think either the CMOS or the 80 tiny on its own is going to be the winner, really. And the 80 tiny on its own is obviously going to drive the dice using this method of pinging off the LEDs. So just in case it wasn't clear before, you've got, it'll be like that. So you've got that one in the middle for just a single one. Right, let's get this soldered up, shall we? We need to put the last ICs in and then the connector with the wire. Oh, I need to roll this trip a little bit to get it in there. Yeah, it doesn't have to be perfect, but I would like it to be simple, interesting maybe. So I think I like the idea of using the vibration sensor to wake up the 80 tiny 85 from deep sleep, or to have it be the actual trigger for the dice, so it could go onto that 4017. But I think there we go. I think the 74HC595, even if it is the low powered version, is kind of a bad idea now, when there are so many other options. Oh, I need to roll that a bit more. And it's the low power thing that I'm mainly interested in with this, because it's mainly going to be just sitting doing nothing for most of the time, isn't it? It isn't going to be something that's used constantly. Let's learn from last time, David, and use some flux. Right, you sitting in? There we go. Right, now just this weird connector. I'll bring my breadboard back in. Now we've got power and ground on these lines here, so we can use that, and I just need to figure out which is which. Well, hopefully I've got them right, but that should be positive and that should be negative. We'll find out in a second. Well, they don't want to stick to the breadboard, but that doesn't look ideal, does it? Ground, that's better. That connector was just garbage. So here's our dice, absolutely not mobile in any way, but we can try it out. So that is meant to be 6. Oh no, it's rolling, is it? Oh, that makes sense. So that was the numbers changing really fast, and then it settles on one. So that's, is that the capacitor charging up and then we discharge it with this? I don't know if I'll be able to make sense of the schematic. So I did something a little bit unfair there without thinking. I blamed this cable, didn't I? Poor cable. It was nothing to do with that, was it? It was that the device was doing this thing, it looked broken to me, and I was still plugging in wires, and I didn't think it was making good contact, when it obviously was. Anyway, I kind of like this thing. There are some interesting things about it, and I can see there's a big old color difference here. Color difference, brightness issue. So this central one is being driven by a single 1K resistor, whereas the other ones all have 470 ohm resistors, and they should be having exactly the same amount of current really, but we measured those and they're about 10% out, some of those resistors. So these ones probably got a higher resistance across them than those two, and this one in the middle, that 1K is giving it a fair amount of current to light quite brightly. It's an interesting layout. These resistors would certainly give me the resistors I wanted to spread across this board here, because I thought it would look like a really interesting effect. I like the idea of it. So yeah, maybe that is an approach I could take and redo this and make it into a stand-up cube. Essentially that's all this is, isn't it? That's the bottom half and that's the top half. But I will look at using just the 4017, I think, because on its own with the vibration switch might be quite interesting. Anyway, I think that's it, isn't it? So, well, next time, hopefully I'll have designed a circuit on a breadboard to show you that it's not just this thing. All right, I'll speak to you all again soon.